as we come to parabolas, and I kind of think of them as the happy or the sad graph, right? So like if the A value is positive, it looks like a smiley face. If the A value is negative, it looks like that. But tell me, what are these three things that are currently on the board? In the last lesson, we spoke about the first one being the standard form. So ax squared plus bx plus c, that's what we call the standard form. What I want to know is, what is this yellow thing over here and what is this green thing over here? So that's my first question for the day. Or if you don't know, then just say, I don't know, and I'll explain. Welcome, Limkhunolo. I see you have joined us. Don't know. Okay, so that is why I'm here to help. So this is called, the second one is called the turning point form. So turning point form. And if a parabola is written in this form, the turning point will actually be minus PQ using this format. And I'll give you some actual examples in a moment, but really, that's an important idea. And then what is the third one? Well, the third one won't get as much attention tonight, but the third one is called the root form. And the root form we use to find the equation of a parabola, where x1 and x2 are the x-intercepts. And so you'll see that probably in the next lesson. So let me give you an example of these formats in sort of a real example. So that's one example of the standard form. And then the turning point form could be something like that. So I'm going to call this let me not make it green, actually. Let me make it, let me leave it green. Okay. I want to know, is the green graph happy or sad? So is it shaped upwards or downwards? And then is the yellow graph happy or sad, based on what you know about parabolas? So the green one, what do you think that shape is going to be? And yellow, what do you think? Is it going to be happy or sad? I use that word happy or sad, but I mean, like, is it going to look like that, or is it going to look like that for the green? And the same for the yellow. So the value that you need to look at is the A value. And because A is positive, I call this a happy parabola. And over here, because A is negative, we call that an unhappy parabola. Now, another thing I want to point out about parabolas is they have something called a turning point. Now, the turning point is literally where the graph turns. Okay, so that's something that's a bit different. And something else that a parabola has is what's called an axis of symmetry. So going through the turning point is a line that basically divides the parabola into two equal halves. You could literally fold the parabola across and it would exactly match. So it's something that I want you to watch out for today, is finding the turning point and finding the axis of symmetry is going to be an important part of the lesson. And the shorthand that we use for axis of symmetry is A/S. So if I had to write, you'll see me write A/S. Then I want to know the equation of that green dotted line. And then if I want the turning point, I often just write TP. And that has two coordinates. All right, now, I want us to use what I said above. This is the turning point form of a parabola. I want you to write down for me the turning point of this parabola above. And I want you to use the bit of information I gave you at the beginning. So what is the turning point of this parabola over here? Pop your answer in the chat. So welcome to CM Tanda, Sange, Silicane. You're just joining us. I'm just doing a little bit of a rundown with parabolas, and you can always catch the first 5 minutes on the recording. And the question I'm asking is, given the parabola -2 bracket x plus 1 squared plus 3, what is the turning point of this parabola? So essentially, I haven't drawn a scale drawing here, but what is that red dot? And I'm going to suggest that you can use this formula. The turning point is minus PQ when it's in the turning point form. So who is willing to use that? Well, exactly. So what is P? P is 1 here. So the turning point will be -1, 3. So that would be the coordinate of that turning point. Okay, so basically when we deal with parabolas, they come in two main forms, or there is a third form, which is called the root form, and that's standard form and turning point form. And what we're going to learn today is how to draw parabolas. So let's get going. Now, for any parabola, you need to find x and y intercepts. So all I want to start with is, can you find me the x and y intercepts for each of these? So find me the y-intercept and the x-intercept for that graph. Find me the y-intercept and the x-intercept for that parabola. And these are parabolas I know because of the power of 2. Okay, over to you guys. Find me those intercepts and pop them in the chats. Because if you can't find the intercepts, you cannot draw a parabola. So to find a y-intercept, we have to make x 0. But actually, that's wonderfully simple because the y-intercept will then just be 0 minus 3. The x-intercept, I need to make y 0. So I'm going to have to solve this equation. But the good news is it's not a very hard equation to solve. And one of the things I have to watch out for, though, is that when I square root both sides, I'm going to get an answer which is equal to the square root of 3, but it's plus and minus square root 3. And so the x-intercept is actually going to be root 3, 0, or minus root 3, 0. So there will be two x-intercepts for the first one. Let me know in the chat if I have confused you with that, or if you understand why there's a positive and negative. Think about this. If I gave you x squared is 4, you know that both x could be plus or minus 2 would be the answer. Okay, I'm waiting for my x and y intercepts for the second one. Okay, what is the y-intercept? That must be the quick and easy one, huh? If I make x 0, this should be 0, 1. And then over here, I'm going to go 0 is minus 2x squared plus 1. Then I'm going to get that. Because I've moved it across. Now I divide both sides by 2, I get half. but I still need to square root both of these. So x is plus or minus. So plus or minus the square root of a half. And the actual x-intercepts are going to be square root a half, 0, or minus square root a half, 0. And I need two of them because of the square rooting. So give me a score out of 10 for how well you understand what I did there. This is called finding the intercepts of a parabola. And if you understand this well, I will definitely move faster. But if you can't do this, then I really need to make sure you can do this first. And I'm going to draw the graph in a second. But give me a score out of 10 for how well you understand this. Okay. Now, when you've got the intercepts and you've got the shape, you can draw the graph. In these particular parabolas, the turning points are actually on the y-intercept, but let me show you what I mean. So I'm going to draw this first one now. And all I'm going to do is put the critical points on the graph. So the y-intercept is at -3. Okay, so -3. And the x-intercepts were at plus or minus √3. So in fact, I'll even just put them here. The graph was a happy graph because of the thing in front. And so if I was drawing this parabola, all I would need to do is that, and then I would label this minus √3. This would be √3. And I would just label the graph y equals x squared minus 3. Now, with this type of parabola, the axis of symmetry is actually on the y-axis. And so the turning point is the y-intercept. And the reason it's so nice and easy and simple is that there is no x term. There's no like plus 2x or minus 3x. It's only an x squared term and a constant. And when this happens, your y-intercept will always be your turning point. So you don't have to do extra work. But the other examples we do today, you will have to. But I just want to make that clear before we start. Let me look at the second one. So in this one, I'm drawing my Cartesian plane. Now, what are the critical points that are important? I should actually have arrows on my Cartesian plane. Well, where was the y-intercept? It was at 1. I'll put it there. Where were my x cuts? Well, they were just there. And the graph was unhappy. So, or a was less than 0, so it looks like this. And then I need to make sure I label the important values. So that's 1, that's minus square root of half. Sorry, that's plus. Plus. This is minus square root of half over here. And then the equation of the graph will just be y equals minus 2x squared plus 1. And so really what you need to draw a graph is you need the shape, you need the intercepts, and you need the turning point. But the turning point you get for free in these types of parabolas. Now, let me upgrade this to a different level. Well, let me give you a moment to take a screenshot if you want, and give me a thumbs up when you're ready to move on. Yeah. So if I want to draw, let's say, this parabola over here, I like to put the process into a 5-step process. Okay, so what are the key bits of information that you need to draw a parabola? Well, step 1, you need to know the shape. Okay, step 2, you need the y-intercept. Step 3, you need the x-intercept. Step 4, you need what's called the axis of symmetry. Step 5, you need the full turning point. So is this parabola, which now is in function notation, is this a happy or sad parabola? Tell me. Is it a happy or sad parabola? Okay, and it's sad, and I'm using that informally, but it's sad in shape. It looks like an unhappy face because of this minus sign here. So you know when you draw this graph, it's going to look like this. What is the y-intercept for this function k? What is the y-intercept for the function k? So to find the y-intercept, we make x naught. So what would the y-intercept be here? Yeah, it's just going to be naught minus 3. Okay, so we've got that piece of information. Now to find the x-intercept, we know from straight lines, we just make y equals naught. And what this gives you is a quadratic equation. Now, you practiced these earlier in the year, and you will often using the formula minus b plus minus b squared minus 4ac over 2a. Find me the x-intercept using that formula. So over to you guys. Tell me the x-intercepts by applying that formula. Sometimes be helpful to write down what a, b, and c are. So a is minus 1, b is 2, c is minus 3. What are my x-intercepts going to be for this parabola? Ooh, are you guys getting a negative delta value? Are you guys getting a negative delta value here? What does that mean? Oh, that's a nice question. So 2a, that would be minus 2, yeah, 2 times minus 1. Okay, I get a negative value for delta, which so minus 4 plus 4 minus 12. I get minus 8. And I haven't got a calculator here, but if I did, it would be giving me an error. Are you getting an error on your calculator for this one? Okay, now the good news is it's not actually wrong. What if delta is negative? It means there are non-real roots, which basically means there is no x-intercept. So when delta is negative like this, it means that the graph doesn't cut the x-axis. So it's not that you've made a mistake, it's really telling you the truth. Okay, now I'll show you when I draw the graph now why it's the truth. Before we do that, we need to get the axis of symmetry. Now, there is a formula we can use to find the axis of symmetry. And the axis of symmetry formula is just minus b over 2a. So using the standard form, what is my axis of symmetry going to be for this graph? What is my axis of symmetry going to be? It's going to be minus 2 over 2 times minus 1. Minus 2 over minus 2, that's 1. Okay, so the axis of symmetry is x equal to 1. And you know what? The turning point is always on the axis of symmetry. So basically, we know that the x-coordinate of the turning point is 1. But we now need to take this 1 and put it back into this formula and find essentially the k of 1. What value does the function k take on when x is 1? So I want you to tell me, what do you get when you put 1 into the function k? What do you get? So minus 1 squared plus 2 times 1 minus 3. Minus 1 plus 2 is 1. Minus 3 is minus 2. Yeah. So the turning point is 1 minus 2. Okay, everyone. Good news is you've done all the hard work. It's now time for the fun part. We are going to draw this parabola on a Cartesian plane. And what I do is I like to divide my Cartesian plane up into two halves using the axis of symmetry. The axis of symmetry was x is 1. So I'm going to go to where x is 1. I'm just going to make it here, and I'm going to draw a dotted line, and I'm going to say x is 1. And that's an important thing because it divides the whole graph into two equal halves. I'm then going to take, what are the key points? Well, I know my y-intercept is going to be down here. It's minus 3. There is no x-intercept. So I'm not putting any dots along here. My turning point is on the line x is 1, but it's at 1 minus 2. So it would be here. What is the shape of my graph? It's an unhappy graph. Oh, now I see why it doesn't cut the x-axis, because it never goes above the turning point. The turning point is 1 minus 2, which means it can never cross the x-axis. And then the only thing I still have to do now is label the graph K. So I've labeled my y-intercept, I've labeled my turning point, labeled the graph, I've labeled the axis of symmetry, and that's it. That's my parabola drawn. Give me a score out of 10 for how well you understood that. There's a 5-step process, and we're going to repeat this 3 or 4 more times tonight. But I want to make sure that you have understood. Well, I want to know how much more explaining I must do, or how much just letting you practice. So give us a score out of 10 for that example. Okay. Keep those scores coming. It's so helpful because remember, I can't see your faces. And so this is how I know. Okay, Sange has asked, is the axis of symmetry the same as the turning point? You know what it is, Sange? It's not exactly the same. It's part of. So the turning point is a whole coordinate. It's the big green dot here. The axis of symmetry is just whatever the x coordinate is of the turning point. Okay, so for example, if the turning point was different, if it was 2, 3, then the axis of symmetry would be x is 2, and the turning point would be 2, 3. So it always has this relationship that the turning point is on the axis of symmetry. Okay, let's do one more example before our break. I want you guys and girls to do the 5-step process for this parabola. So I think we can all see that this is an unhappy parabola. But then from that point onwards, I want you to work out the other important details for me. And then I want you to tell me when you have done them with a done in the chat. So it's a 5-step process, and then you can sketch any parabola you like. Okay, so what are you guys getting for your x-intercepts? I think it's going to be a bit of a messy one because that's 8, that's 160, that's 224. So you can give them to me in decimal if you like, or root form. What is, whatever your calculator gives you. Maybe you can. What are you getting for your x-intercepts? You get a 7. Did anybody get an exact 7? I thought it would be messy. Yeah. So x is equal to minus 1.74, or x is 5.74. Yeah. So those are the two x-intercepts. Now, to get the axis of symmetry, you're going to have to use this formula for when it's in standard form. So I want to give you some more time to do that. And then we're going to take a break. And then once I see we've got the axis of symmetry and turning points. So minus b would be minus 8 over 2 times, so this is 2. So the turning point will have a value of 2. As its x coordinate, what is the y value of the turning point? And it's basically you need to take the 2 and put it back in g. So g of 2. So yeah, I get minus 8 plus 16, which is 8 plus 20. So I get 28. So those are the 5 key bits of information. And when we come back after the break, I am going to show you how to draw this parabola using those 5 pieces of key information. But let us all have a little break. So you know how this works. Just for you and for me and for everyone, just so our brain takes care of us, we just do a quick break. And today is going to be just a quick one, not a long one, because we have to do quite a bit of practicing today. But let's just start with some gentle sort of swaying from side to side. And as you relax, you'll rotate more. Okay. Then we're going to shake out our arms. Shake out this arm. Shake out the legs. Okay, let's roll the shoulders and roll them back. Roll them forward. Okay, to the side. In circles going back. Shake out the arms one more time. Shake out the legs. Okay, and then just some jumping jacks to make sure you're all awake and nobody is snoozing off on me. So get some space, make sure you don't whack anyone or anything, and we'll do 12. In 3, 2, 1, let's go. 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. And that is that. I'm not going to do a puzzle today because I think we're going to be a bit short on time because these graphing questions do take a while. But we will get back to that. Okay, so how do we draw this? So step one, where is my axis of symmetry? It's at x is 2. So I call this the halfway line, and I go x is 2. Stephen, yes, what is your question? Can you hear me? Can you hear me,
Yes,
Stephen?
sir. Please maybe explain the turning point again.
Can you hear me, Stephen?
So can you
Yeah,
hear me?
perfectly. Yeah,
I can hear you.
yeah, that's all good. I think there's a
Maybe
bit of a
please
lag.
explain the turning point and how you got negative 28.
Oh, positive. Okay, let me explain that. So, there's a bit of a, I can hear myself. All right. Let me put you on mute. I think part of it is the feedback loop. So Stephen's asked, how did I get the 28? So step one is I use the formula minus b over 2a, and I go to, there's the minus, so it's 8, but it's minus b, so that's why it becomes minus 8. And then you go 2 times a, and a was minus 2. So that's where that comes from. And that gives me a value of 2. Now that value of 2, that's a little bit dark, but anyway, yeah, underline it rather. That value of 2 is the axis of symmetry over here. Okay. Now what we do is we take that 2 and we put it back into the original thing. So the g of 2, and we get minus 2, 2 squared plus 8 times 2 plus 20, which gives us 28, and is the second part of the turning point. Now that turning point would be 228. So let's say it's up here, because let's say that's in line with 28. That's where I would be. Okay. So let me try and draw the rest of this graph. So what are the important bits? Well, I know that there's a y-intercept at 20, and that is below the 28 for the turning point. There's an x-intercept at minus 1.74, and there's also one on this side. Well, let's see if we can fit. Is it an unhappy graph? It is an unhappy graph. So I can see, and this is just an approximation graph. This is going to be the minus 1.74. This is going to be the 5.74. That is going to be the plus 20. And this is going to be the 228. And then I need to label the graph G. Okay, let me know in the chat if you followed that. Thumbs up, thumbs down, the normal. Just want to get a feel because I want you to do another one by yourself now, if we're all. But if not, I love the question from Stephen. So please, that's the perfect idea where you get to kind of, one of the lovely things about MathsLive is we set it up that it's live. So you can literally ask questions as we go. Okay, now we are going to sketch this parabola, but there's something a bit different about this. So before I even start my 5-step process, I know it's a parabola because of the power of 2 that I can see on the screen, right? But what is different about it? If anybody feels like, you can always put your hand up and tell me audibly, or you can put it in the chat. But what is different about this example compared to the last example? It's not in standard form. Yeah, it's actually in what we call the turning point form. You might have missed it if you weren't here at the very beginning, but we discussed the difference between the turning point form and standard form. And the thing about the turning point form is that you can easily get the turning point because it's literally the turning point form. So what I'm going to do is I'm going to ask you, before we even start drawing this graph, can you write down for me the turning point of this graph G? can you write down the turning point? Now, earlier in the lesson, when we said the standard form of it, oh, sorry, the turning point form is like this. The turning point is just minus PQ. So if I had to look at this graph, I know I'm going to have to do my 5-step process. But I'm actually asking you, because it's in the turning point form, can't you just write down the turning point at the very beginning? So minus P, at the moment, P is minus 5. So what's minus 5? It's 5. What is the Q value going to be? It's going to be, well, 4. And so the turning point is 5, 4. And we can literally read it straight off the graph when it's in turning point form. The other thing that's good is if I know the turning point, I know the axis of symmetry is x is 5. And so we just worked out the turning point. So look at all that lovely working out we saved just because we recognized it was in the turning point form and we knew how to use this little idea. I will talk more about why it works maybe in a future lesson, but for now you just have to know it. But then you guys have to tell me, is it happy or unhappy? What is the y-intercept? What is the x-intercept? I want you to work that out for me now. I think this is unhappy. And the reason it's unhappy is because of the minus a value. But you have to find me the y-intercept and the x-intercept now, which also might be a little bit tricky. Not too bad, but, you know. See if anyone can get me the y-intercept and the x-intercept. So to find the y-intercept, I make x naught. But this is a bit more interesting than before. It used to be that it was very easy, but I think some of you are going to get caught out here. Minus 5 squared is 25, but then it's a minus. My y-intercept is minus 21. Ooh la la. Did anybody get caught out by that? Did some of you write 4? I bet some of you wrote 4. I've been doing this long enough to know. some of you definitely wrote down 4. Okay, so the y-intercept is minus 21, but watch out because we tend to think the y-intercept is always easy. But when you have it in the alternate or the turning point form, finding the y-intercept actually takes a bit longer. The x-intercept is also a bit different, but in some ways it's a little bit easier. So to find the x-intercept, you have to solve that equation. I'll give you a little bit of time to do it, but it's actually not that hard. See if you can get me my x-intercepts. And I'm going to divide both sides by minus 1, and then I'm going to end up with this. Now, the problem is the square, but if I square root both sides, then that square will go away. But I just need to be careful because when I square root 4, I actually get two answers. And so we get 2 is x minus 5, or minus 2 is x minus 5. So what are my final x-intercepts going to be? What are my final x-intercepts going to be? So if I bring the 5 across, I should get x is 7. And if I bring this across, I get plus 5 with minus 2, I get 3. So my x-intercepts that I get are going to be 7 and 3. I want to give you some time to draw this graph by yourself now. So it's over to you to draw, but I want you to say done when you are done, and then I will come along and draw it with you. But I want to give you a chance to practice this. And the important things that you need to use when you draw your graph is your intercepts, which you have, and the turning point, which is sitting over here. So gonna give you some time and then say done in the chat, and I'll come along and we'll do this together at the end. So just say done in the chat when you are done drawing your graph. Okay, let's see if I can put my graph between these points. Now, it doesn't have to be perfectly, actually, let me use a different color because it doesn't contrast nicely. So let me put red. Oh, no, let me. Oh, that's really not the prettiest graph in the world, is it? But you get the basic idea. So it's going through, it's got minus 21 as the y-intercept. It's got 3 as the x-intercept there and 7 on that side. And then the turning point is going to be 5, 4. And then I need to label the graph G. Now, obviously, I shouldn't have these dodgy endings. It should be a bit more curvy, but it's a bit hard when you're doing it digitally. So what did we do today? We looked at the different forms of the parabola. We looked at how there are 5 important areas that you need to work out to draw a parabola. We also looked at how when you draw it from standard form, it's slightly different, the process, to when you draw it from turning point form. Although the 5 steps are the same, the turning point form, you can actually get the turning point straight away. And then you also need to practice putting these points on a graph and drawing them so that you get a roughly accurate graph. Okay. In the next lesson, what I'm going to do is I'm going to look at how we can find the equations of parabolas. So if we are given information and you're given a drawing, how can you work backwards to get the equation of a parabola? And that's going to be the focus of the next lesson. And then I'll also maybe mix in some intersection points into that, like how do you find the intersection points of parabolas and straight lines in the next lesson.